lesson is over ratio and proportions. The objective, students will be able to use ratios and proportion to find measurements from scale drawings and models. So let's do a couple of kind of examples here to start off. So what if this is our class? So if you look at this, these are our classmates. We have 12 people in the class. So make sure we know that. So the first question, what is the ratio of band members to athletes in this class? Now, one thing you want to make sure you realize is what order they go in. Band members to athletes. So band members come first. So we have 1, 2, 3, 4 band members. So band members, we have 4. We have 1, 2, 3, 4, 5, 6 athletes. So the ratio would be 4 over 6. I like to reduce that down to 2 over 3. Now you can also do your ratio, occasionally they do it where they do 4 to 6 this way. Again, you can reduce that down to 2 to 3, but I'm going to stick with doing the fractions because that's a lot easier to do some of this other math with, and that's a lot more of what we're used to. What about this? What's the ratio of athletes to band members? So now we're doing the opposite way. Now the athletes are first, and the band members are second. So again, we still have the same numbers. So there are 4 band members. And 1, 2, 3, 4, 5, 6 athletes. So now again, the order is important. So now the answer would be 6 to 4, or again, I would use a fraction. And again, make sure you are reducing your fractions. And that's another reason why I like to write it as a fraction rather than using this way, because if you write it as a fraction, it's a lot easier to reduce that. What is the ratio of students to teachers? Well, we said there are 12 of these are students. And 1 teacher in the class. So the ratio, again, make sure you know the order is teachers to students. So teacher comes first, so it's 1 over 12. I guess I should say comes first or is on top, because this way it would come first. But again, as a fraction, we're putting that up on top. What's the ratio of the number of athletes to the total number of students? So we still have 1, 2, 3, 4, 5, 6 athletes. So we still have total number, we still have 6 athletes, and the total number of students is 12. So we have 6 over 12. So half of the students are athletes. Again, you can do it this way. I just like the fractions a lot better. What's the ratio of left-handed students to total number of students present today? Well, again, total number means the denominator is going to be 12. So let's see left-handed. We have 1, 2, 2. So 2 out of 12. So that means 1/6 of the students is left-handed. And what is the ratio of students wearing long sleeves to the number of students wearing short sleeves? So long sleeves first. If you go through, we have 1, 2, 3, 4, 5, 6. So we have 6 with long sleeves, which means we have 1, 2, 3, 4, 5, 6 with short sleeves. So the ratio would be 6 over 6, which is 1, or 1 to 1. Make sure you use those fractions. So let's start solving some of these proportion problems, and hopefully you guys remember this, but we're doing cross multiplying for this. So remember, cross multiplying, first off, you can only use this if you have 2 fractions with an equal sign in between there. The problem with cross multiplying is a lot of people start doing it when they have the problem that's x over 3 plus 10 over 15 is equal to 8. And they see this problem, excuse me, and they try to cross multiply this. You can't cross multiply this because this is not equal it's plus. So remember, you can only do this if you have two fractions with an equal sign in between, or two ratios that are equal to each other, however you want to look at it. So cross multiplying means we just take the top of one fraction, multiply it by the bottom of the other. So 15 times x, doesn't matter what order you put it in. And then the top and the bottom of the other one, that's why it's cross, is equal to 3 times 10. And again, you're leaving the equal sign in the middle. There's a lot of people that get that confused and they try to put plus or division or something crazy like that. So once you've done this, now we can solve. 15 times x is 15x is equal to 3 times 10 is 30. Divide both sides by 15. We get x is equal to 2. Now again, it doesn't matter what order you put the 15 and the x or the 3 and the 10. You could have switched those and put x times 15, 10 times 3. But also it doesn't matter what order you put the whole thing. If you switch these completely, you'd still get the same exact answer. Switch these completely, that's completely fine. So this one, I have y and 5. I usually put the variable second because that's easier to write as just 5y, but again, you don't have to. And then 2 times 10 or 10 times 2 doesn't make any difference. Oops, should have put that up there. So that makes this one 20. Divide both by 5, excuse me. Y is equal to 4. Not really too bad. And again, this should be stuff that you did back in Algebra 1, and you might not have done it a lot, but it should have been easy stuff from Algebra 1. I mean, you're just doing one step, and then it's a solving problem that you did a bunch in Algebra 1. So we're getting some bigger numbers. You might have to use your calculator. That's okay. We have 30 times m is equal to 20 times 120. Now, I know some of you guys are going to start taking the shortcut and just putting 30 times m is just 30m. That's totally fine. That's up to you, but I'm going to keep on doing it this longer way just so you see that I'm multiplying those, because for problems like number 10, the next one we get to, it's going to be a little bit different. So 30 times m is 30m is equal to 20 times 120, should be 2400, I believe. Yeah, or 2,400, whichever way you want to look at it. Divide both sides by 30. We get m is equal to 80. So again, a little bit bigger numbers. It's okay. You guys have a calculator. Don't make it harder than it is. Now, number 10, this is where it gets a little bit more complicated. A lot of people, this is a mistake they make. 4 times x plus 5, and so they do 4 times x plus 5 like this. That's not the case. That's why I always put these in parentheses, because it's 4 times x plus 5. If you just put 4x plus 5, that's not right. So make sure you're doing that. Same thing with this. It's 16 times x plus 2. Now again, you could do it the other way, x plus 5 times 4. It's just a little bit weird to distribute that way, so I always put the binomial second, if possible. And then you distribute. That's the biggest thing people forget. 4 times x and 4 times 5 is 4x plus 20. A lot of people have a 5 for that. 16x plus 32. And then solve this equation. Subtract 4x. Again, there's several different things you can do from this part. I always like to combine my x's first, and I try to do it so I end up with a positive x in my next step. Again, you obviously don't have to. There's 4 different things you could do with that step. 20 minus 32 is negative 12. We end up getting negative 1 is equal to x, or x is equal to negative 1. Now, the good news is we don't have any that are quadratics, but you could have one, just to get your mind working, where if we mixed it up and said like we have x plus 3 over 5 is equal to x plus 2 and 6. When you cross multiply these two, you'd end up with a quadratic, and so you might have to solve with factoring or quadratic formula. We may get into that, but not this lesson. So number 11, same thing, we're cross multiplying. So we have 3 times y is equal to 15 times y minus 2. Again, I like to put the binomial, the thing that has 2 terms, I like to put that second. I think that helps you guys. 15 times y, and 15 times -2. Again, a lot of people forget that second term. You have to make sure you remember that. So this is an instance. I like to combine my y's first, and I try to keep them positive, but this one it's a little bit easier if you just change them to negative. It's all kind of your call. Just be careful. 3 minus 15, just make sure that ends up -12. Yeah, so I divide by -12. So for this answer, you can either take that and just simplify that. So if we divide both of those by 6, I think that's the easiest way. I'll do -6. So that's 5 over 2. If you want to do it that way, that's fine. Or personally, if I were you, the easiest way, just put it in your calculator. -30 divided by -12. Round to 2 decimal places if you have to. This one we don't. It's just 2.5. Either way works, but I personally think if you can simplify the fraction really quickly without thinking about it, like if you have 2 over 4, that's obviously 1/2. If you want to do that, that's fine. But if I were you, if you have to do any thought process to reduce, I would just go ahead and make it a decimal. And last one, we have 2 times y is equal to 3 times y minus 3. So that's 2y is equal to 3y minus 9. Subtract 3y. -y is equal to -9. Remember, that's not quite close enough. We have a negative here, so I have to divide each side by -1. A couple other ways to look at that one, but I think that's the easiest. We end up with y is equal to 9. So let's move on to some real-world problems. So this example 1, a scale model for a car is 10 inches long and 5 inches tall. So the scale model, one thing I like to do right away is I'm going to make this a fraction. But before I make it a fraction, one of the important things is staying organized with what you put in the numerator and what you put in the denominator. So I'm going to put long and tall. I just like to put a fraction that is L over T. So my L is on top, my T is on bottom. We'll talk about that in a second. So now when I do the fraction for this, it's 10 over 5 because I put my length on top, 10 over 5. Then it says the actual car is 60 inches tall. Now this is talking about tall, so that's got to go on the bottom where we put my tall. It says what's the length of the car? So I don't know what the length is. You can use X, you can use L, whatever you want to do. Once you have this, now we cross multiply. 10 times 60 is equal to 5 times L or X, doesn't make any difference. 10 times 60 is 600, is equal to 5 times L. Divide both sides by 5. 600 divided by 5 is 120. So the length is 120 inches. Now, obviously, hopefully you realize this, but one of the most common mistakes is over here. When it says it's 60 inches tall, you put 60 on top, and then you put your X or whatever variable on the bottom. You're going to miss it, and I think that's the hardest part, and that's why I always start by making a fraction over here with just my variables or with just my measurables. That way I know the length is always on top, the tall is always on the bottom. So the largest submarine in the United States Navy, our Ohio class, each submarine is 560 feet long, so 560 feet long. You purchase a scale model of the submarine. The package states the scale is 1 inch is 16 feet. So I'm going to do inches on top and feet on bottom. So the scale is 1 inch to 16 feet. What's the length of the completed model? So we want to know the length of the model. Well, 1 over 16. The actual feet is 560 feet. I want to know how many inches that's going to be. For this one, I'm just going to use X. Again, it doesn't really matter. So we have 1 times 560 is equal to 16 times X. So it's 560 is equal to 16X. Divide both sides by 16. So 560 divided by 16 is 35. So my X is 35. So that is 35 inches. Now, one real quick thing, and I don't want to take a lot of time to do this, but I honestly am a little bit nervous that I got this one wrong, so let's double check some things. So it was originally 560 feet long. but we're changing it so every 16 feet is only 1 inch. So we have a bigger number, 16, and every 16 we're reducing that down to 1. So if I started with 560, if we're going from 16 down to a smaller number 1, this 560 should end up being a smaller number, 35, and it is. So that's a good way to check your work. If that doesn't make any sense, that's fine. Just remember how to do it this way, where you make sure you always are consistent with putting inches on top, feet on bottom, or vice versa. You could have done the same thing real quick with feet on top and inches on bottom. So you could have had 16 over 1 is equal to 560 over x, which would have been 16x is equal to 560 times 1. Same exact math. It doesn't matter as long as you're consistent. If you put feet on top, both of the feet have to be on top. So we have the same scenario in the model. If the model is approximating 5 inches tall, what is the height of the actual submarine? So the last one we had said it's 1 inch to 16 feet. So I put inches over feet, and so I had 1 over 16. It's saying it's 5 inches tall, and again, that's the model. So that's the other thing you could do. You could label this as the model over the actual. Either way, it's the same. So we have 5 inches over, I don't know if that's X or Y, whatever you want to call it. That's not a bad idea. That's how I should have said it. The model over the actual. So 1 times X, 5 times 16. That's X is equal to 5 times 16 is 80. But remember, this is feet. So it would have been 80 feet tall. So yeah, the inches and feet totally work out for this one. I guess I should be careful because if the actual thing is in inches and the model is in inches, that could run into some problems. So yeah, it's not a bad idea. Instead, we have our model over the actual. That's what I should have done. If I wasn't too lazy, I'd redo this video and replace that, but alas, that's a lot of work for just stating that. So an architect wishes to represent the length of a room with a 5-inch segment. So again, we're doing a scale drawing. So if the room is actually 18 feet long, write the ratio of the scale length to the actual length. So now again, we have the ratio of scale length to actual length. So the scale length has to be on top because we're writing a ratio. Before, we weren't writing the ratio. We were just solving for x. We were trying to find the height. We were trying to find the length. So the scale is represent the length of the room with a 5-inch segment. The room is actually 18 feet long, right? A ratio of the scale. Okay, so the scale, we want 5 inches to represent the length. So that means the scale is 5 inches. But this is going to be the tricky part. Over the actual, that's 18 feet. So you could say, I'm trying to think of the easiest way to put this answer. So here's the thing. We could do this by putting 5 inches to 18 feet. If we just want to write it out that way, and that's what they did for this last one. They said the scale was 1 inch to 16 feet. So we could just say 5 inches to 18 feet. So 5 inches to 18 feet. That'd be fine. If you want to say 5 inches over 18 feet, I'm okay with that. Just make sure you're labeling these because the label is important with this one. And on the same theme of that, if you want to, you could change this feet. If you want to make it a little bit easier to understand, you could change that to inches. So there's 12 inches in every foot, so that would be 5 inches to 216 inches. Or you could change this inches to feet. That'd be a little harder because you're ending up with a decimal that I don't really like. But the easiest way, just go ahead and either put it in this way or this way. Just make sure you're labeling inches and feet. If the room is actually 54 feet wide, how long how long of a segment would the architect use for his blueprint. So we have the scale over the actual. We had 5 inches to 18 feet. Yeah. And they say the room is actually 54 foot wide. So we're talking about the actual distance. That's 54 feet. And we want to know what would the blueprint be. So what's this going to be? So 5 times 54 is equal to 18 times x. That's 270 is equal to 18x. Divide both sides by 18. 270 divided by 18 is 15. So we have 15 is equal to x. Whoops, that does not work. And that's in inches. So your scale would be 15 inches would be the length of the segment, which would be the length of the room. All right, so this one, different type of example. So we were just talking about scale drawings, but this one is the perimeter of a rectangle. JKLM is 56 centimeters. The ratio JK to KL is 4:3. Find the length and the width of the rectangle. So this is the rectangle, JKLM. I always like to draw a picture just to make sure. The perimeter is 56 centimeters. So that means if you add up all these sides, so I'm just going to call this, let's just do length and width. This is the length, this is the width. When you add those together, length plus width, add all the sides together, that's your perimeter, that's 56. So that's 2 length plus 2 width is equal to 56. We can't solve for either of those. They say the ratio of JK to KL is 4:3. And maybe, I will be honest, this I kind of just did kind of on impulse, so we might not use that very much, but we'll see. So the ratio of JK to KL, so the length to the width is 4:3. So what they mean by that is whatever you divide, when you take the length over the width, it's going to end up being 4/3. Find the length and the width of the rectangle. So if it's like that, I'm going to say it's 4 times the length is equal to 4 times the width, because if it was 4L over 3W, no, let me take that back. So since it's 4:3, I'm going to call my variable x. So 4x and 3x. Because if it was 4x over 3x, the x's would cancel, so that gives us the ratio of 4/3. So I did put all this stuff. That's really nice and handy, but we don't really need that. I apologize. I was jumping the gun. So we have 4x plus 3x plus 4x plus 3x, because this is also 4x and 3x. That's got to be equal to 56 centimeters. We combine our like terms. We have 4 plus 3 is 7, plus 4 is 11, plus 3 is 14. So we have 14x is equal to 56. Divide both sides by 14. X is equal to 4. So that's really nice, but it says find the length and the width. Well, now that we have x is equal to 4, we can plug that back in. The length is 4 times 4. So that's 16 centimeters for the length. The width is 3 times 4, which is 12 centimeters for the width. And honestly, if you mix those around and said the length was 12 and the width was 16, that's fine. And ultimately, if you want to check your work really quickly, the ratio has to be 4:3. So if you do 16 over 12, if you reduce that, that's got to be 4:3. That's the whole idea. For a rectangle of a yard is 80 feet. The ratio of the width of the yard and the length of the yard is 3:5. Find the dimensions of the yard. So now that we've done this, the first one is a little bit more complicated, but now it shouldn't be too bad. The area, the perimeter is 80. And the ratio is 3:5. So 3:5, actually technically the way I drew it, it should be the 5 up here, but it doesn't matter at all. It doesn't matter if you're drawing it to scale, and it's going to be 5x and 3x, because again, 5, I guess I should do 3x over 5x, those would cancel to get you 3:5. Then the perimeter is 80, so this is 5x and 3x, so add these together, 5x plus 3x plus 5x plus 3x is equal to 80 feet. So that is 16 when you add those together. Divide both sides by 16. X is 5, and again, it says find the dimension. So x being 5 is awesome, but that's not our answer. We need to plug that in. So 5 times 5 is 25 feet, and 3 times 5 is 15 feet. And again, it doesn't matter which one you actually call the length or the width. And again, if you want to check, make sure you do this. 15 over 25 has to be 3 over 5, just like they said. And the last example, Milton and San Jose are 9 inches from each other on a map that has a scale of 1 inch to 13 miles. How far apart are the real cities? So let's do the map over the actual. So the map is 1 inch over 13 miles. And Milton and San Jose are 9 inches from each other. That's funny because I thought those were names, and it just dawned on me those are cities. So 9 inches, because that's the scale from the map. How far away are the real cities, the actual cities? We don't know what that is. So 1 times x is equal to 9 times 13. You don't actually have to label inches and miles, but sometimes it's kind of nice to make sure you know what those are. And that ends up being 117. Now, I'm sure there are other ways to do this that make it a little bit easier, but I like this way because if they ever have, instead of 1 to 13, it's like 5 to 13, this method is the easiest. So I know some of you guys are like, oh, I can just do that in my head. I just multiply 13 and 9. That's awesome, but sometimes it's going to be a little bit harder if you do that way. So make sure you know how to do it this other way. Fairview, Madison are 36 kilometers from each other. How far apart would the cities on the map be if the scale was 1 to 3? So again, I'm going to put my map on top and my actual on bottom. So my scale is 1 to 12. And they're 36 kilometers from each other. That's the actual distance. So that's got to be 36. And I want to know on the map. So now I have 1 times 36 is equal to 12x. Divide both sides by 12. We end up getting 3 is equal to x, which is your centimeters. And again, that's where it's a little bit tricky because this last one, a lot of you guys said, oh, I just multiply 13 and 9. I don't need to do all this complicated fraction stuff and cross multiplying. But then on this one, a lot of people do that. They take 36 times 12, and that's not right. So you have to make sure you're being careful. So if you have any other questions, make sure you're letting me know. Make sure you're taking good notes. And definitely email if you need anything.